number 4 from the 2013 Higher Maths paper 2. Right, here we've got this, it looks like an area question and also mentions tangents to curves. First part, the line with equation, this line here is a tangent to this curve, just call that 2 at the point A, 0, 3, and naturally because this curve twists and turns, it then passes on to meet it again or to cross it again somewhere else at B. It says, show that B is the point negative 3, 3. Well, that's handy because that'll let me check my answer and then work out this area that's enclosed between the curve and the line. Well, the first bit, find where it cuts B. Well, that means if I'm looking for an intersection, I'm going to substitute. So I'm going to substitute 2 in 1. Although you'd probably just write it as equate, but strictly speaking it was a substitution. Instead of that y, I'm going to write this thing here, but you could just say equate if you wished. So I've got this expression is equal to that expression. And of course that's 2x plus 3, it's just that part of that plus side toppled over on me at the point of intersection. Take it all over to one side, and of course I've got a cubic expression here, so x cubed plus 3x squared. The 2x is going to knock out that 2x, the 3 is going to knock out that 3. So that's just going to leave me with equals 0. So, whilst I was anticipating my little synthetic division, because I was going to factorise a cubic expression, it's just evaporated in front of me. Because what I've got here are common factors. Because the whole process is, take it to one side equal to 0, and factorise it. But the factorisation's trivial, because what have I got? There's a common factor of x squared, and that leaves an x plus a 3. So the two solutions would be x equals 0 or x equals negative 3. Now, at x equals 0, that was the point A. And of course notice it was the x squared, so that 0 really appeared twice. That was a double root because it was a tangent. This is the single cut, this is at B. Just put a wee note of that effect. At A, x equals 0, which means at B, x must equal 3, negative 3. Now it's just a case of work out the y coordinate. You could put it into either of these equations, but of course I'm going to put it into the easy one. So I'll just take a note. If x is negative 3, that means that y is going to be 2 times negative 3 plus 3, negative 6 plus 3, which is negative 3. Which means B is the point, as they said, negative 3, negative 3. There, it couldn't have been easier. Last part said, find the area enclosed by the line and the curve. Well, the area will be the integral from, where did they start? X was negative 3. When did it stop? X was 0. Of the top, which is this expression. Now I know what you're thinking now. Why don't you just pop down that expression you had when you equated them, that x cubed plus 3x squared? Simple reason is that might not be the right way around. It will be those two terms, but it might be their negatives. Annoyingly in this case, it does turn out to be that. But you should always just play safe and show it this way. It's the top, take away the bottom. The y coordinate of the top of each of these little strips that you're adding up along the way to form this area. The y coordinate at the top's given by that, the line's at the bottom. Minus the 2x plus 3 times the width of the strip dx. That's what I want to integrate. And of course, yes, it does come to, in this case, just x cubed, because the 2x takes away the 2x and the 3 takes away the 3. It does just come to x cubed plus 3x squared. But I'm sure you're required to show top take away bottom. And then it's a simple matter, it's just add 1 to the power, divide by the power. Up to 4, divide by 4. Up to 3, divide by 3. Well, that'll be handy, because that's just x cubed. I'll not show the 3 over 3 here. Work it out at 0 and negative 3. Work it out at 0 first of all. Well, that'll just be 0, just put that in. That's 0 and 0. Now work it out at negative 3. So I've got a quarter of negative 3 to the power 4 plus negative 3 cubed. So what's that then? So it's negative of, well, that'll be positive with a power 4, an even power, and 3 to the power 4, that's like 9 times 9 is 81 upon 4. This will be negative, because it's an odd power of a negative, and that will be 27. So that's going to be 27, 108, negative 27, the negative of negative 27 upon 4, which is 27 upon 4 square units for the area. Or I could have got that easier. I suppose I could have got it easier just by putting it into a calculator, because it was paper 2. Probably could have got it easier for taking out the factors, the cubed, negative 3 cubed, because it appears in them both. Then I'd have a negative 3 cubed, which is negative 27, leaving me a negative 3/4 plus 1. So that'd be a quarter of negative 27. I could have got that without any of that. Still, it's done. There it is. That's the answer.